So, a while back I watched Erasmus's Flat Earth video. In that video, he suggested this one by Dubey. Today we get into it to see how wrong they both really are, because if I'm going to dismantle this nonsense, I'm going to get to the root of the problem. Welcome to the Nexus. Today we're going to determine whether or not we live on a globe or a flat plane. Now, Dubey's whole video is over 2 hours long, and it is 200 individual points, but they can be divided for our purposes into categories, because I am damn sure not going to repeat myself for every single one of them when one explanation applies to all of whatever is in one category, nor am I going to subject you to one of the most boring voices I have ever heard. From basic physics to aviation and no-fly zones to Freemasons, he literally listed 200 points where he fucked up somewhere. Throughout watching this madness, he pulled pretty heavily from the 1800s and repeated himself a lot, rephrasing the same proof or the same phenomena from another 9 or 10 locations in an effort to get to that magic 200 number he was shooting for. I broke it down into 8 categories, and while some of them will overlap in places, it's about as organized as I could get with this asshole. We'll start with the horizon. Now, he, along with every flat earther out there, says it appears flat and level and always rises to eye level while having no perceivable curvature, and cites the laws of perspective and vanishing points as explanations for that. Here in reality, however, the horizon is literally the curvature itself. Often cited as evidence of this is watching a boat disappear over the horizon, with a common response being that if you use binoculars or a telescope, you can see farther and bring the boat back into view unobstructed. However, refraction, which we will cover in a bit, accounts for this over areas of temperature differentials, and the goddamn boat still disappears from the bottom up eventually, no matter how strong your optics are. A much harder point for them to disprove would be to have a flat earther stand at elevation on a mountain, for example, and have his buddy observe him from a sufficient distance to have most of the base of the mountain hidden behind the curvature. He is still visible at altitude, but the base of the mountain, which is lower and closer to the viewer, would be obscured from view. That makes the law of perspective and vanishing points both useless and stupid as explanations, because the base of the mountain should remain visible, while the flat earth fucktard should be too far away to see if this horseshit is to be believed. Now that leads into how someone can stay firmly planted on a globe, regardless of location on it. The answer, of course, is gravity. There are many instances of flat earthers pouring water over a racquetball or basketball and saying that since it flows right over and off the surface, that it disproves gravity, and that buoyancy and density better explain that which is plain stupid. See, density and buoyancy don't work absent gravity or a constant acceleration. I've got the experiment to show that linked below. If it isn't gravity, that means we would be accelerating upwards at a constant 9.8 meters per second. If that were the case, then we would reach the speed of light in under a year, about 353 days actually. Now, that is a problem because the speed of light is a universal speed limit. Nothing with mass can travel at or faster than the speed of light, and the energy needed to reach that speed hits infinity. That is a problem, so what about gravity? Gravity pulls towards the center of mass, and since we are on a fucking planet, the gravitational pull of Earth rips the water off the comparatively minuscule mass of the balls they use for these stupid experiments. The mass of an object matters quite a bit here. We'll leave the moon out of this for a second. Earth mass is in at about 5.972 times 10 to the 24th kilograms. For those less acquainted with scientific notation, it's this number. Pretty hard to conceptualize, but the point I need to make here is that gravity doesn't just pull north to south. It pulls pretty uniformly across the entire sphere towards the center of mass, with little variations based on sections of greater density, which means it has more mass compared to its surrounding materials. Negligible overall, really. This means that all of the Earth's water is pulled uniformly to the surface, because water only accounts for about 0.02% of Earth's total mass. It is overwhelmed by the force of gravity to stick to the surface, so to speak. This makes rivers run downhill from our perspective, and why spinning a tennis ball in the air to sling water off of it is both stupid and wrong. The ball doesn't have enough mass compared to the water on its surface. Remember that we are more than 179,000 times less massive than the Earth. This is one reason that intuitive perceptions can be and are flawed. There are areas that are higher in sea level than others, which explains the flow of water from higher elevations to lower, like I mentioned before. This also accounts for various canals and whether they need locks or not. Water at around the same relative elevation does not need locks, and seas are less susceptible to tidal forces due to having less water in them than oceans. This is why the Panama Canal has locks, while the Suez does not. Panama connects the Atlantic and Pacific Oceans, which are more massive and being affected more by the moon's pull, which we will cover more in a moment. The Suez connects the Mediterranean and Red Seas, which remain relatively at the same height regardless of tidal forces. This is why on most architectural and engineering projects, curvature is not accounted for. The ground is at the same relative height from sea level, and they are building on what is essentially level ground, with the curvature being negligible and simply following the route on the ground in front of them. However, there are projects like the Akashiki Kaiko Bridge in Japan. This bridge was completed in 1998. It is the longest suspension bridge in the world, and you can see it visibly curved from this angle. That is because of the curvature this nearly 4,000 meter structure has to account for. If it did not account for that, it would not end where it does. That is why that 8 inches per mile squared thing is nonsense. That formula is for measuring a parabola or an arc, not a sphere, which has a different equation entirely. It's okay for short distances, but the error involves stacks over greater distances, which results in comparisons like this graph. Obviously, there's a problem with this math, which is why the 8 inch per mile squared thing isn't used except as a shorthand over small distances. This calculation was proposed by Robotham, which Dubey cites often, and is an error, which is why his experiments are completely fucked and give erroneous results, so he and his calculations should not be used unless you want to sound like an idiot to those who know better. While we're on the topic of bridges and water, we need to talk about tides, which is yet another point Dubey completely fucked up on. Tides are caused by gravitational forces from the moon primarily, with notable influence from the sun too, but we'll set the sun aside for this. Now, the Earth, as we've already seen, is massive, but the moon is certainly no lightweight compared to us. It masses in at around 7.35 times 10 to the 22nd kilograms. Again, for those less acquainted with scientific notation, it's this number. It's about 81 times less massive than the Earth. Now, it stays in orbit around Earth because the Earth is the larger body and is pulling on it with more force than the moon is exerting on the Earth. But this pull is still not negligible. And to be completely accurate, the moon exerts enough force to shift the planet slightly in its orbit around the sun. The effect on large bodies of water is more noticeable because there's more of it to affect, causing bulges of water to be attracted to the moon. The moon only exerts enough pull to move the water, but not strip it off the planet because it is not massive enough or close enough to do so. And since the Earth is 81 times more massive, it is able to hold the water but still feels the tug, so to speak, since the water, being a liquid, is able to flow and move in response to the influence. I have never seen a model from flat earthers to account for this, and don't expect one really. If the tidal forces of the moon and sun aren't responsible for the tides, then what is? Do the elephants on the back of the Great Ahtueen slip every so often, or what? That brings us to eclipses, which is another thing the flat model can't explain. Now, the way the flat model is set up, solar eclipses could work, but the path of totality doesn't mesh with the flat model at all. It would have both bodies moving rather differently from what they tell us their model allows. Lunar eclipses would be impossible on a flat model, but not on a globe, which accounts for them perfectly. Solar eclipses track where they should, and lunar eclipses work. Now, the reason lunar eclipses work the way they do on a globe is the same reason shining a large light at your body from a distance at night makes a faded shadow behind you. Some of the light is passing your body at a steep enough angle to slightly illuminate the shadow you cast. It's the same thing here, but on a larger scale. And since the light is passing through a lot of atmosphere, it gets that reddish tinge from being slowed. Speaking of, we need to talk about reflection of light off the moon. Now, the moon is not a perfect reflector, but it still reflects light from the sun. Dubey seems to think this is a problem, but if that logic holds, then you would not be able to see light off a ball in your hand or light off yourself, so that doesn't work. There is one thing I almost forgot to cover. The claim that no larger body has ever affected a smaller one in an experiment on Earth. That isn't the case. The experiment that gave us the gravitational constant did it. The Cavendish experiment in 1798 provided our first measure of the gravitational constant and showed that mass attracts mass. The setup was so sensitive that Cavendish had to observe it through a hole in the wall with a mariner's telescope to prevent his presence throwing it off while he observed the interaction. Now we have much more precise measurements with lasers and a vacuum, but for the late 1700s, he was pretty close, and it is actually pretty damn impressive. Now we need to talk about light and refraction. First, let's cover Olber's paradox. Basically, Olber's paradox stated that if space is full of stars, then why isn't the Earth bathed in perpetual light? By all rights, the sky should be a white background of light with the number of stars and galaxies that are out there, right? Well, there is one main reason that isn't the case. See, the speed of light is constant and nothing can physically travel faster than light, but that doesn't apply to the space itself, which is expanding faster than light. This doesn't break the physics because the medium of space is carrying us and everything else with it, while light, which is traveling through it, is being carried as well. Locally, the effect is unnoticed, but looking at stellar bodies further away from us shows that they are redshifted, which means that they are traveling away from us. That's why when you hear cosmologists talking about the universe, they're talking about the observable universe. Beyond this cosmic horizon, space is expanding too fast for the light stellar bodies are emitting to ever get to us. We will never see them. It is for this reason that the universe doesn't constantly bathe the planet with visible light. Most of it is shifted to the low end of the spectrum because of the light waves being stretched out in the intervening expanding space. It is below our visual threshold, which is only a small sliver of the EM spectrum, and when it does get here, it has to contend with our atmosphere, which affects the spectroscopy even more. This is also why stars seem to twinkle, because of the motion of the atmosphere and temperature differential of the light passing through it. Speaking of which, we need to talk about mirages like this. The Chicago skyline. Now, we spoke about light traveling through the atmosphere briefly on lunar eclipses, but deeper in the atmosphere there is a more exacerbated effect due to the denser atmosphere at sea level. Gravity is holding our atmosphere to the planet. The higher you go, the thinner the air is until it is next to non-existent in the vacuum of space, which isn't entirely accurate terminology since there are gases in space. It's just that they're spread out to about 1 atom of hydrogen per cubic centimeter in deep space. We define space to effectively begin at the Kármán line, 100 kilometers above mean sea level. Seeing as a thinner atmosphere exists at higher altitudes, the difference in air pressure means that higher elevations of air mass won't be moving as quickly, but this speed difference is negligible because of the thinner atmosphere and less overall air resistance. Now, this mirage and all other similar phenomenon, including visibility of lighthouses at great distances, is accounted for by this atmospheric refraction, which causes light to bend through the atmosphere to cover greater distances, but under specific conditions only, and the visibility will be different if those conditions vary. It takes a few known variables like altitude, temperature, and barometric pressure to calculate this, but it is doable and accurate to a decent margin of error. Before we move on to the section that really pissed me off, let's cover hotspots, tracing sun rays, and reflections off water. The quickest one is the whole reflection off water thing. It works the same way that light reflects off of the moon or any other non-flat surface. It looks straight to an observer and doesn't reflect all over the surface because the light that bounces directly at you is what you see. If it were closer, then more light would be reflected or emitted in the case of the sun, and you would see a difference. Now, about hotspots on clouds seen from airplanes. This isn't the sun being close to the Earth. If it was, the people on those planes would be fucking dead. Clouds are condensed water, specifically water crystals at these altitudes. They are highly reflective and create this optical illusion. The sunray phenomena is also explainable in this way. Light is traveling perpendicular when it reaches the Earth, but contending with our atmosphere creates this effect. The atmosphere when full of clouds, creates an illusion similar to looking at a straw through a glass of water, with the convergent point being the upper reaches of our atmosphere. It's the same thing with the mirages we talked about earlier. The next section pissed me off because of my background in aviation and because of the lengthy explanations needed to correct all his errors. This will probably be the longest part of this whole thing. Starting with the navigation aspect, we'll be talking about the compass, a simple navigational tool flat earthers love to cite but don't fucking know how to use. See, Dubey and his ilk seem to think that the Earth only has one pole, that being the North Pole. Well, technically the South Pole, since the North Pole of magnets are attracted to what we define as north. We know that the Earth doesn't have one pole because if the Earth had just a monopole, then we wouldn't see evidence of the North Pole switching every so often. Monopoles don't work like that. That's why they're fucking called monopoles, as in one pole. Let's take a look at how Earth's magnetic field actually works, with a lesson I feel like most flat earthers slept through, so I'll give them more of an education than they obviously ever got in school because they failed to properly understand simple concepts. You're welcome, flat earthers. Now pay attention. The Earth has a few layers, being the crust, mantle, and the inner and outer core. For this, we'll focus on the core. The outer core is a mass of molten iron and nickel, which is under constant motion. The movement of all that material generates an electromagnetic field in what is known as a dynamo. The material is spinning in the same direction of the planet, and because of this, the electromagnetic field forms poles towards the top and bottom of the planet. They don't match perfectly with the rotational axis or the North Star, which is why maps have a deviation specific to the area they cover and the year they were printed for the three different types of north and south that we have. Yes, there is a star in the southern hemisphere that can be used like the North Star called Sigma Octantis or Polaris Australis. It is barely visible to the naked eye. So for star navigation in the southern hemisphere, the Crux constellation or the Southern Cross are used for navigational purposes. Anyway, there's more going on with the planet's dynamo than you realize, but this is a basic primer. The electromagnetic field shields us from much of the harmful radiation and charged particles the sun emits and shunts that energy to the poles, which is why we get the northern and southern lights, as that energy ionizes the atmosphere in those locations. Compasses align with the lines of magnetic force no matter where you are on the planet. If you were to go to the North Pole and find yourself right on top of magnetic north with a free-floating magnet, it would point straight at the ground. Same as if you went to the South Pole. Now we will get into aviation navigation instruments. First, we need to start on the ground. Aircraft runways, contrary to what people may think, are not randomly numbered. If you don't work in the field, you likely wouldn't know this next bit. Runways are numbered based on the compass heading they correspond to. For instance, runway 90 would align with magnetic east, or 90 degrees, while runway 27 would align with magnetic west, or 270 degrees. They are kept to a two-digit number for simplicity and clarity over radio. Runways are labeled according to the compass headings, but they are set up to take advantage of the prevailing and dominant wind patterns in the area. Aircraft take off and land into the wind to generate the maximum amount of lift possible. This is especially important on landings because in order to land, you have to approach stall speeds, and landing into the wind makes it easier to stay aloft at those slower speeds. Next, we need to discuss flight plans and flight paths. The aviation industry makes money as long as the planes are flying. The more places they go, the more passengers they can swap out to keep a mostly full cabin to make the flight more cost-effective. There are direct flights, but they are rare because they are more expensive for the airline and in turn for the passengers. The lack of multiple stops actually costs the airline more because of the difficulty in filling seats. That's why flights don't seem to go where they logically should. You may only want to go to New York, but to make the trip worth it, you will likely stop off in Chicago O'Hare and Atlanta, Georgia, at the very least, probably switching aircraft while your first plane loads up with people going to Orlando, Florida, or Fort Worth, Texas. The more seats they can fill, the cheaper the flight overall will be, and that isn't even counting cargo being shipped. Your flight and travel time will be longer, but the trade-off is a cheaper ticket price. Now, specifically, Dubey mentioned that there have never been flights over Antarctica or across the South Pacific or Indian Oceans. Flights over Antarctica are not done because it isn't safe. Air at altitude is cold, very cold, and icing is a legitimate concern even in the higher latitudes of the southern hemisphere. Flying a passenger aircraft over a frozen continent is unsafe due to the extreme temperatures, which will further strain the de-icing systems, and should the plane crash, it would be no hope of rescue virtually from the desolate and hard-to-traverse continent. It isn't worth the risk. As for the South Pacific and Indian Oceans, this goes back to the direct flights I mentioned earlier. They exist and do fly those routes, but it isn't cost-effective, so they fly routes that take them to places where they can pick up passengers and keep the planes as full as possible. No mystery if you know the field and how it works. He also mentioned that there are no circumnavigation flights in a north to south direction. This is again due to safety concerns of flying over a frozen continent, and with the fuel load necessary would require a commercial-sized airliner with ox tanks. It's not worth the risk. So now we need to talk about what is happening to an aircraft in the air, and there are a couple of key points he fucked up on. First, sticking with navigation, we need to talk about the attitude indicator and the attitude gyro. The attitude indicator is a visual indication of your angle relative to the ground. It's a pretty simple setup. Brown is ground and blue is the sky. The thin line in the center is the representation of the aircraft. It isn't easy to gauge your angle relative to the ground by just going off of sight alone, so in my flight sim I rely heavily on my instrumentation, including this one. Now the indicator can be set up a couple of ways, analog or digital. Some analog versions have the gyro portion inside the indicator itself, while others and the digital versions receive a signal from a gyro separate from the indicator itself. Either way, we need to talk about the inside. Now, flat earthers are actually correct when they state that a gyro will resist movement, and as such, during adjustments of flight angles to maintain altitude, the gyro should essentially spin backwards as the aircraft travels over the surface of the sphere. There is a way to correct for this, which is deceptively simple. See, while the gyro is functioning, and it is in a level state, so to speak, there are 4 air outlets that provide equal airflow and keep the gyro itself level. During flight, when the aircraft is tilting in the pitch and roll channels, the flow of air is not interrupted as the aircraft is essentially moving around the gyro. As the gyro shifts due to traversal over the planet, however, the pendulous vanes that control the airflow through the gimbal assembly are affected. As the gyro misaligns during travel across the Earth, the vane openings will be affected by the pull of gravity, closing off one or more of the 4 openings and opening the others to allow greater airflow, imparting a force on the gyro itself, forcing it back to an upright position in relation to the surface. As it corrects, the vane openings will reopen, keeping the gyro in proper position. The position of the indicator is set on the ground before takeoff, as during spool up the indication can be off on occasion, so a manual adjustment of the indicator is needed. Now, this is a vast simplification of the gyro, but accurate for the purposes here. Now, the reason planes don't fly into outer space is because they can't. Not because of a firmament or any physical barrier, but because the engines on aircraft need oxygen to run, which means that there is a hard limit on the altitude they can achieve. This is obviously model dependent. No oxygen means a flameout, where the engine shuts down and will not restart until it is a lower altitude. While we are in the air, we need to talk about atmospheric motion on a globe. As I mentioned earlier, the atmosphere is held to the Earth's surface by gravity, with more air mass closer to the surface than at altitude. Now, the atmosphere isn't just subject to inertial forces that effectively pull the atmosphere with the rotation of the planet, which is why we don't experience winds in excess of Mach 1. We do experience various weather patterns, including wind patterns that travel opposite the rotation of the planet at altitude, and this is caused by temperature differentials from the heat of the sun. Hot air rises and cool air sinks, which is the driving force behind our weather patterns. Those sections of the atmosphere that travel opposite the rotation of the Earth are at altitude, where the air is thinner and thus not as strong as it would be at sea level. No big mystery here either. This is also why flight times are not substantially different from east to west versus west to east. Anything that leaves the surface of the planet like an aircraft is still experiencing inertia and being pulled with the rotation of the planet. Since the atmosphere is moving this way, as well as flying into the air mass, presenting drag, and flying with it doesn't increase the speed much, the direct opposite. Remember that unless the object in question is an ICBM, there will be stresses on the aircraft that will put a hard limit on the speeds it can achieve. Dubey did bring up a question of motion sickness and why movement in a car or a plane can make some people sick, but the rotation of the Earth does not. The rotation of the planet is constant, and it doesn't shift or speed up or change its position noticeably. And since we were born into that inertial reference point, we don't get motion sick from the motion of the planet. You need to also remember how massive the planet is and how large the orbit around the sun is as well. We are talking about a 15 degree out of 360 degree rotation per hour with about a 2 degree lateral movement per day around the sun. Relatively slow on the whole. We are talking about one rotation every 24 hours. If you get on anything else on this planet, like a merry-go-round, and have someone push you fast enough to rotate once in a 24-hour period, you are going to wonder if it's moving at all. Speaking of space, we need to talk about that. Specifically, launches into space and orbital maneuvering. Let's take a trip to Cape Canaveral, Florida. Now, even though mission control is based in Houston, Texas, there is a reason launches in the U.S. are done from here. Cape Canaveral is close to the ocean, which is important for safety reasons. See, launches don't always go off cleanly. It's a very dangerous gig to be an astronaut. Take the Challenger disaster, for example. The shuttle exploded mid-launch with a total loss of life of all crew. The debris landed in the ocean off the coast instead of raining down overpopulated areas, which is why this site was chosen as the launch facility in the first place, not to cover up anything nefarious. The reason launches don't simply go straight up is simple. Gravity from the planet is constantly pulling the craft back down. In order to overcome that, the craft must achieve orbit, meaning that it has to be moving fast enough to achieve constant free fall. To do this, the craft must move fast enough laterally to constantly miss the planet, so to speak, because gravity is still trying to pull it and every other orbiting body to the surface. That arc you see in launches is how they attain that velocity. It's called the roll maneuver. It's the same thing with satellites that are moving laterally fast enough to maintain orbit around the planet. Now, like I said, the atmosphere extends out to what is defined as space and beyond. So low Earth orbit objects do experience minuscule drag from the atmosphere, which is why they have to adjust their orbit to keep from falling back to the planet. This is accomplished with the expulsion of gases from thrusters, which work effectively at high altitude where there is next to no atmosphere. The last thing we need to talk about is the temperatures orbiting bodies experience. Yes, low Earth orbit objects are primarily in the thermosphere, which can reach 4,500 degrees Fahrenheit. However, there are ways to thermoregulate that equipment. For one, the objects in question are generally in orbits that do not have them in those high temp areas on the sunlit side at all times. They traverse to the night side regularly, which helps in thermoregulation. The use of highly reflective materials and radiators to also reflect or shed that heat is how some satellites can stay in geosynchronous orbit, as in over one spot over the planet. And even with that, since they're over only one spot on the planet, they're still rotating to the dark side of the planet every 12 or so hours. Satellites are not black body objects that absorb all that heat energy, and the temperature in the thermosphere is in a section of the atmosphere with very little air, so there isn't much to heat up and conduct to the equipment. You are assuming that satellites are not engineered to dissipate that heat and that the atmosphere is acting like it would at sea level, where those temperatures would be a big fucking concern. Neither of which is the case. There's a lot more in the way of engineering that goes into thermal regulation, but it's a bit much to get into here, especially considering the length this video already is. The last couple of things we need to discuss navigation-wise includes Lieutenant Charles Wilkes' 1838 to 1842 expedition, which did involve charting about 1,500 miles of Antarctica's coastline. Now, while I could find no trace of the quotations you linked to him about being off by whatever amount, it isn't really surprising. Remember that this is one of the first expeditions to the South Pole area, to Antarctica itself, and that stellar navigation and navigation in general, including maps, was incomplete in the area, and they were effectively winging it, using the Crux or Southern Cross, which we've already established are not steady along with dead reckoning, which isn't the most accurate way to navigate. So his being off course once he was able to navigate using the sun is actually to be expected and not a problem for the globe model at all. While we're on the subject of Antarctica, we need to cover its circumference, which isn't a thing since it isn't a circle. It does, however, have about 11,165 miles of coastline all total, considerably less than what you flat earthers seem to think it is. As for another point you tried to make with the distance between Sydney and Nelson, Australia, it's only about 1,300 miles, not 1,550. A commercial flight can make that in just over 2.5 hours. Your erroneous calculation seems to have been pulled straight out of your ass because you are not accounting for the smaller circumference at lower latitudes. Your calculation is easily correctable if you knew anything about math, which we've already established that you do not. I think we'll call it here for now. We'll discuss the rest next time.